Hi folks, it's Alan here and I'm back in my electronics cave. I'm currently working on this, which is actually a commission for one of my customers. And basically what this is designed to do, it is designed to take in two BNC inputs, pass them through a whole series of circuitry, reclock those inputs and spew them out of digital outputs. Again, BNC outputs. So it's two BNC in to two BNC out. The main thing is it reclocks things, and most importantly, it also optically isolates them. So there's a bunch of optical isolators here, there's a load of power supply isolation in here. Turns out though that one of the most challenging things here is because this is designed to be used with a particular chord DAC. It's the chord M scaler, which is a preprocessor, and the chord Dave DAC, both of which are extremely high quality pieces of kit, and actually therefore it needs to run at really quite high frequencies, 768 fs, so basically 768 times the frequency of the standard source signal. And that means that off-the-shelf latching chips that allow me to link the SPDIF signal and regenerate a clock from it simply don't exist. So I'm having to make my own. Now I'm actually building in here multiple different stages of phase lock loops. The first one though is the one that I'm working on, and buried underneath this pile of oscilloscope probes here is a little tiny phase lock loop chip. In fact, you can just about see it there underneath that yellow wire, a little phase lock loop chip. Unfortunately, that phase lock loop chip, while it produces a fantastic clean output signal, it won't latch onto random data, which is of course what's coming in here from SPDIF. So I'm basically having to build my own phase detector circuit that goes along with this. So I'm using a design called a HOG phase detector, which I'm prototyping on these two boards here, and I have to say it is proving to be an interesting challenge, and I can see why not very many people are doing this kind of thing. But, you know, fingers crossed it's working so far. Once I've generated a basic clock signal, I'm then planning to use two VCOs and another phase lock loop in order to basically take any residual jitter out of that, because there will be plenty at that point because it's based off random audio data. And that basically should give me an extremely clean, extremely jitter-free signal going on the outputs. And I have to say it's almost working. So you can kind of see here, the white trace in the middle is actually the original clock trace, and the green trace at the bottom is a clock that has latched onto that. And actually you can see they've latched on pretty well. Unfortunately, it's latched on pretty well at slightly the wrong frequency. So I just need to do a small amount in order to kind of tweak that, because it's basically latched on with a master frequency of about 69 megahertz there. Actually, it needs to be about 45 megahertz. It's running 1.5 times too fast. And that's one of the downsides with this type of phase detector, because actually the fact that it is designed to latch onto random data means it will basically latch on provided the phase is anywhere close to, or it will latch on provided the phase is correct, and it doesn't really care what the frequency of the signal is, which is an interesting challenge. So what I'm going to have to do here is limit the voltage controlled oscillator in this circuit so that it will only operate within the desired range that I want, which is basically 45 to 49 megahertz, depending on what the input frequency signal is. And once I've got that, and once I've basically put some limitations on there, fingers crossed it will latch on cleanly, and it will latch on cleanly at the right frequency. So yeah, here's hoping that all of this works and it ends up being worthwhile. Fingers crossed, this should be a great little product, but I have to say the research in this one has been a lot more complicated than even I thought, and I guess that this was going to be a little challenging going into it. Anyway, wish me luck.